Welcome back to Learning with me here at MPB. I am Ms. Killen. We are still in our Unit 7 working with quadratics. We are on to Lesson 7 today. We are using Vertex form to graph quadratic functions. So let us go ahead and dive on in to our slides. All right, so let's do some review. We've got our vertex form, which is a times x minus h squared plus k. We've learned that our h is our x value of our vertex and our k is our y value of our vertex. We know that our a values tell the direction that our quadratic parabola is going to open up or down. It also tells us if it's going to stretch or if it's going to compress. Now remember, we are looking at those absolute values of my A. If it's larger than 1, it's going to stretch, means it's going to get skinnier. If the absolute value is less than 1, that means it's going to compress or it's going to get wider. And we're also comparing it to its parent function. Now right here, the blue would be considered my parent function. Now if I stretched it, it would look like the green. And if I compressed it, it would look like the red. So there are two examples when we are comparing to that parent function. So let's look at this. Franklin throws a football off the Marriott Hotel balcony. The function w of t equals negative 16 times t minus 3/2 squared plus 136, where t will represent the time in seconds, and the height of the football is modeled in feet. So we have some questions about this passage. Using what we've learned from the previous lesson, determine, then explain how the graph will open up. Well, as we have seen in the past lessons and on that last slide, we are looking at this A value right here. Now it is a negative 16. So what is that negative 16 going to tell us? So when my A was larger than 1, I did something. And then when my A was less than 1, I did something. So when my A is less than 1, I am going to what? Compress. So we're not even having to worry about that one. Now if it's a negative, that means it's going to open downward. All right, so the next one says, is the equation in vertex form? Well, what I do to make sure that I help myself to remember is I write my vertex form, and we have y equals a times x minus h squared plus k. I have that in my negative 16 times t minus 3/2 squared plus 36. So yes, it is in my vertex form. Is this graph considered stretched or compressed when compared to its parent function? And this would have been the parent function. So let's go back and look. My 16, negative 16, is that larger than 1 or is it smaller than 1? What did we say? Awesome. It is going to be a compression because it's smaller than 1. So that's how we're using these different terms, these different parts of my vertex formula to answer questions about a quadratic. So let's look at the next one. It says, let's do some more practice. Now, Marcy's function she is using for her math presentation is f of x equals x minus 3 squared plus 4. Help Marcy give her presentation on all the key features of the quadratic function. So let's look at A through D. First of all, I need to tell what my A value is. Well, you may be looking at your page or looking at my screen and saying, Ms. Killen, I don't see an A. Well, just because I don't see a number does not mean there's not one there. If I don't see something, that means it's an understood, yes, an understood 1. So if you need to put that 1 there just so you can have that placeholder, that's okay. That's a good job and that's a good way of thinking about it. So my value of A, I'm going to say is number 1. Now what did we say that my A tells about? Yes, my A tells me how I open up and down, and if it's stretched or made skinnier, or if it's pushed down and compressed. So my A is 1. Exactly right. I would say that it was going to stay the same width or not skinny or not compressed as my parent function. Good job. Now it tells me to find and graph the axis of symmetry. Now where did we find out the last lesson that our axis of symmetry comes from? Exactly right. I need to look at my vertex coordinates. So where do I find the coordinates of that vertex? Exactly right, in my function. So remember, I have a times x minus h, or opposite of h, squared, plus k, where this is my x value and this is my y. So let's go ahead and look at that function. I have opposite of -3. I'm going to have a +3. And then I'm going to have +4. So let's go ahead and graph that. So I've got 1, 2, 3, 1, 2, 3, 4. This is going to be my vertex. Good job. Now, it also says for letter C, plot my y-intercept in my mirroring point. Now, you may be saying, Ms. Killen, how do I get that y-intercept from my vertex? Well, that's easy. We're going to solve for my constant. So let's see what we're going to do. So for me to do this, what I need to do is make my equation, and I'm going to make my x a 0, because when I have my y-intercept, I have 0 for my x and then a number. So I'm solving for this number, and my x is going to be 0. So let's go ahead and work this math. So I'm having to solve for this y that I don't know yet. So 0 minus 3 is -3. -3 squared plus 4. You can plug that in your calculator, or -3 squared is 9. 9 plus 4 is 13. So my y value for my y-intercept is going to be at 13. So let me put some more up here. My eraser don't want to erase. 1, 2, 3, 4. Okay, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There it is. Now, I want us to pay attention to this. It says plot the y-intercept, and it also says the mirroring points. Now, the mirroring points would be the same y value, and it would be the same amount of distance from my vertex from one side that is to the other. So if from my vertex I go to the left 3 to find my y-intercept, how many will I go to the right to get that mirroring point of that y-intercept? 3. So I'm going to have 4, 5, 6, and go up to my 13. And this is what my parabola is going to look like. Now remember, Ms. Killen cannot draw a line to save her life, so we're just going to take that for an account. Now it says, find and plot the x-intercept. Now when I look at this parabola, what is the one thing that you notice? It does not touch, cross any type of way of the x-axis. So I do not have any x-intercepts. So there are no real roots. We learned that a couple of units ago. So I do not have an x-intercept. Awesome. Let's look at the next one. Sometimes quadratics are not going to be written in vertex form. There are several ways to find vertex form. Completing the squares is a great one. So let's use this, and we're going to use the method of completing the squares. Now let's just dive on in. We know what we have to do. We have to make this equal to 0. Awesome. Then I'm going to move my old constant to make way for my new constant. All right, so I'm going to add 2 to both sides and rewrite x squared minus 4x. Leave room for my new constant equals 2. Now to have that new constant, I'm going to take b divided by 2 squared. So I have -4 divided by 2 squared. -4 divided by 2 is -2. -2 squared is a +4. So I'm adding 4 to both sides. So let's rewrite that to make it a little prettier. All right, now the next step we have to do is break this down into our factoring. So I'm going to go ahead and factor this left side. Let's see what it looks like. So I'm going to build my two binomials, x and x. I need the factors of 4 that add to give me a -4. Remember, we said what was in here before I squared it is what we would put in our two binomials. So I'm going to have a -2, -2. When we see something the exact same that's written twice, I can write it as something that is squared. So now I'm solving for my x values. So let's go ahead and complete this. I am taking the square root. I have x minus 2 equals the square root of 6. Now, can I factor anything out from under that square root sign? Well, the only things that I have as factors of that 6 would be 2 and 3, and both of those are prime numbers, so I can't factor anything out. I'm going to have to leave it as plus or minus square root of 2. Still need to get that x by itself, so I'm going to add 2 to both sides. So my x, let's put it right here, x equals 2 plus or minus the square root of 6. So now I have found what my x values are. So let's go back and look to see what the rest of my features are. For my vertex form, it would be before I took the square root. So my vertex form would look like this. I'm going to have to move my 6 back over. So x minus 2 squared minus 6. Opposite of -2 is going to be a positive 2. And my -6, this is going to be my vertex. To get my x-intercepts, I can take this 2 plus the square root of 6 and 2 minus the square root of 6 and find out what my roots are. And I'm just going to go ahead and put this. My roots are a -0.45 and a positive 4.449. That's simple calculation skills. You can plug that in. So now I need to know what my y-intercept. Now, how did we say a while ago that we found that y-intercept? Exactly right. I'm going to erase some of this so I have some room. And let's get a different color since we're doing something a little different. I'm going to take this x minus 2 squared minus 6. I want to find my y-intercept. When I have my y-intercept, my x is 0. So I'm just going to work this math and solve for y. 0 minus 2, -2. -2 squared is 4. 4 minus 6, y equals -2. So my y-intercept equals 0, -2. Now, there's another way that we can figure out all of these functions for this problem. It's Desmos. So let's pull up Desmos and see what we find. So I'm going to pull Desmos up, and I'm going to put in my original problem. So we've got x squared minus 4x minus 2. Down here is my vertex, positive 2, -6. We have that. Here is my y-intercept, -2. And then we have our roots, -0.4490 and 4.4490. So we have all of our different features. We had Desmos find it, and we did it pencil paper. So we have those. We want to make sure, guys, that we are doing this math and we are double checking ourselves. That's why I'm doing it pencil paper and then I'm going to calculator. Or that's why I'm doing it pencil paper and that's why I'm going to our Desmos calculator. Because that is one of our wonderful tools that we have in our toolbox, is that calculator on Desmos that helps track our math to make sure that we've gotten it right. Good job. Now, it is time, our favorite time, for us to master. So let's look at this. Anna needs help rewriting her equation in vertex form, then solving for all the features and graphing. Her equation is 4x squared plus 16x plus 5. Now, I'm going to work it. You and your table partner or you by yourself work the problem, get your answers, talk about it, and then come back to me and let's see what we got. All right, let's see what you got. Let me check. You check my work and see what you got. So the first thing I'm going to do here is look and see my problem is. I've got 4x squared plus 16x plus 5. Well, I'm going to do the completion of squares. I like that one. So let's go ahead and work it. So to do the completion of squares, I'm going to make it equal 0 and move my old constant. I'm going to subtract 5. So I have 4x squared plus 16x, making room for my new c, or my new constant, equals a negative 5. To find that new constant, I take b divided by 2 and square it. So when I take, oh, before I do that, hold on, Miss Killen, you went too fast. You're right, I did, guys. Here, what should I have done before I went ahead and got that new constant? I needed to do what? Exactly right. I need to take out my GCF. So what do I have as a GCF on this side? I'm going to take out a 4. You're exactly right. Glad y'all caught that because I kept on working. All right, so now we're going to be able to get our new c. So how do I get that new c? Same way. Take my b, divide it by 2 and square it. 4 divided by 2 is 2. 2 squared is 4. Whatever I do to one side, I do to the other. But we got to wait a minute. I'm not just adding 4. I have to put back in that GCF. So I'm going to take my new constant, multiply it by 4, and then add it. So 4 times 4 is what? 16. So I'm going to add 16 to both sides. So now I have 4 times x squared plus 4x plus 4 equals 11. Good job. Now I'm still going to do the same problem. I'm going to factor it down and move everything away from that variable. So let's see what we got. So I've got my constant, or my GCF. I'm going to take x and x. Now what did I say goes in those two binomials? It's what was up here. So I'm going to put a positive 2. When I see something that's the exact same written twice, I can put it as squared. Good job. Now, I need to move everything away from that variable. So the first thing I'm going to do is move that GCF. Since I'm multiplying by the GCF, I'm going to divide. And I'm left with x plus 2 squared equals. 11 over 4 does not give me a pretty number, so I'm just going to leave it as my fraction. To get my x by itself, I'm going to take the square root, and we're going to finish it over here. So I have x plus 2 equals the square root of 11/4, and we know that as positive or negative, plus or minus. Still got to get that x by itself, so I'm going to subtract on both sides. So x equals negative 2 plus or minus the square root of 11/4. So we have what our x-intercepts are going to be. Negative 2 plus square root of 11/4, negative 2 minus, excuse me, the square root of 11/4. So now let's go back to here and find some more features. So let's go back here. All right, I need to find that vertex form. So I have 4x plus 2 squared, and then I'm going to have to move this 11 back over to here. So if it's positive, when I move it back, it's going to be negative. So now that I have my vertex form, I can find what my vertex coordinates are. So my vertex coordinates is opposite. So that's going to be negative 2 and negative 11. So I'm going to put negative 2 and negative 11 there. Awesome. Now I need to find that y-intercept. Still going to take this same formula right here. I'm solving for my y-intercept. So that means my x is going to be 0. So I have 4 times 0 plus 2 squared minus 11. So let's go ahead and put our stuff together. 4, 2 squared, 4 times 4 minus 11. Well, everybody knows 4 times 4 is what? 16 minus 11. And what is 16 minus 11? 5. So my y-intercept is going to be what? 0, 5. So we found all these different points. Let's pull up Desmos and just double check our work, okay? Let's look at Desmos. So I'm going to pull Desmos and put in our original formula, which is 4x squared plus 16x plus 5. Let's pull this down. Ms. Killen, I can't see your vertex, so I'm going to have to zoom out. There we go. -2, -11, got it. If we take that, what was it, -2 plus or minus the square root of 11 over 4, you will get these two answers. And then my y-intercept, 0, +5. Awesome. Awesome. Now, we don't want to forget, absolute value of A is going to tell us if we're stretching or if we're compressing. We need to remember that a vertex is that H and K value. Axis of symmetry is the what? It's the H value or the X coordinate in our vertex. And then my parent function is always going to be that X squared, no matter what it is. All right. We've got this lesson. We're almost getting to the end of our quadratic functions. I want you to make sure that you are practicing on these because the more you practice, the better you're going to get. I am so glad that you came to learn here with me at MPB. I want you to have a great day.